Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P3, Variant 3, May-June 2021. Let's get started. Ray owns an electrical shop. The table shows the opening times of the shop. Work out how many hours the shop is open in 1 week. On Sunday and on Monday, the shop is closed, so that's 0 hours. The time duration from 8 o'clock to 12:30 is 4 hours 30 minutes, and the time duration from 13:30 to 17 o'clock is 3 hours 30 minutes, and so 4 hours 30 minutes plus 3 hours 30 minutes is 8 hours. The time duration from 8 o'clock to 13 o'clock is 5 hours, and the time duration from 14 o'clock to 19 o'clock is also 5 hours, and so 5 plus 5 is 10. So now the total time duration is 4 times 8 hours plus 10 hours, which is equal to 42 hours. Saeed buys 2 ovens costing $440 each, 4 grills costing $184 each, and 3 fridges costing $1,280 each. Calculate the total cost. The total cost is equal to the cost of getting the 2 ovens, which is $440 times 2, plus the cost of getting the 4 grills, which is $184 times 4, plus the cost of getting the 3 fridges, which is $1,280 times 3. When we type this into the calculator, we get $5,456. Alice buys 3 batteries costing $2.85 each. Work out how much change she receives from $10. The change she receives is equal to $10 minus the cost of getting the 3 batteries, which is 3 times $2.85. This gives us $1.45. Sherry works 32 hours 1 week, and she is paid $8.48 per hour. In another week, she works 37 hours. For each hour over 32 hours she works, she is paid 1.25 times her hourly rate. Calculate her pay for the week she works 37 hours. Her pay would be equal to the total amount she earns for working 32 hours, which is 32 times $8.48, plus the amount she earns for the extra 5 hours she works, which is 5 times 1.25 times $8.48. This gives us $324.36. Ray buys a toaster for $36. When he sells it, he makes a profit of 40%. Calculate the selling price of this toaster. The selling price of the toaster would be equal to the original cost of the toaster, which is $36, plus the profit, which is 40% of $36. This gives us $50.40. May and Jian each make a 4-faced dice as shown in the diagram. The faces on each dice are numbered 1, 2, 3, and 4. May throws her dice 90 times and records the scores. The pie chart shows the results. Write down the mode. Using the pie charts, we can point out the mode by identifying the sector with the largest angle, and so the mode is 3. Work out how many times she scores 1. The number of times she scores 1 is equal to the sector angle for 1, which is 76 degrees divided by 360 degrees times 90, which is equal to 19. Gian throws his dice 90 times and records the scores. The pie chart shows the results. Write down the median. The pie chart has been sectioned from the smallest to the biggest number, starting from this point. This means to get the median, we need to measure 180 degrees from this point. The 180-degree line cuts through the sector for 2, and so the median is 2. Write down two different comparisons between the results for May and the results for Gian. One of the differences is that May has a mode of 3 and Gian has a mode of 1. And another difference is May has a median of 3 and Gian has a median of 2. The diagram shows a scale drawing of Joel's rectangular garden. The scale is 1 centimeter, represents 8 meters. Find the actual area of his garden. On the scale drawing, when we measure the length of the rectangular garden, we get 10 centimeters. Using the scale conversion, we get the actual length to be 10 times 8 meters, which is 80 meters. For the width on the scale drawing, we get 6 centimeters. And so the actual width would be 6 times 8 meters, which is equal to 48 meters. So now, the actual area of the garden would be 80 meters times 48 meters, which is equal to 3,840 meters squared. The diagram shows a rectangular gate FGHJ in Joel's garden. GJ equals 2.1 meters. FG equals 0.85 meters. Find FJ. To get FJ, we can apply the Pythagoras theorem. This gives us GJ squared equals FG squared plus FJ squared. When we make FJ the subject, this is what we have. GJ is 2.1 meters and FG is 0.85 meters. When we type this into the calculator, we get 1.92 meters rounded to 3 significant figures. The diagram shows Brenda's rectangular garden. There is a patio in the shape of a quarter circle. She wants to grow grass in the shaded part of the garden. She needs 40 grams of grass seed per square meter. Grass seed is sold in 1 kilogram bags, which cost $6.80 per bag. Calculate the cost of the grass seed she needs to buy. First, we can start by finding the area the grass would occupy. To get this area, we subtract the area of the patio from the area of the garden. The area of the garden, which is in the shape of a rectangle, is 85 times 24 meters squared. And the area of the patio, which is in the shape of a quadrant, is pi times 24 squared divided by 4 meters squared. When we type this into the calculator, we get 1,587.61 meters squared, rounded to 2 decimal places. Now that we have the area the grass would occupy, we can find the mass of grass seeds required for the area. We've been told that for every square meter, Brenda needs 40 grams of seed. So we want to find the mass of seeds she would need for an area of 1,587.61 meters squared. This is what we are calling X. When we cross multiply and make X the subject, this is what we have, which is equal to 63,504.43 grams. Now that we know the mass of grass seeds required, we can find the number of bags of seeds she needs to get. A bag contains 1 kilogram of seeds. So we want to find the number of bags that would be needed for a mass of 63,504.43 grams. When we cross multiply and make x the subject, this is what we have, which is equal to 63.504. This means she needs to buy 64 bags in total. The total cost of the 64 bags would be 64 times the unit cost of a bag, which is $6.80. This gives us $435.20. Simplify 3a minus 5b plus 2a plus b. First, we can rearrange the terms to group like terms. 3a plus 2a is 5a and minus 5b plus b is minus 4b. So we have 5a minus 4b. P equals 3x squared minus xy. Find the value of y when p equals 90 and x equals 5. When we plug in p equals 90 and x equals 5 into the given equation, this is what we have. 3 times 5 squared is 75. When we group like terms, we have 5y equals negative 15. And when we divide both sides by 5, we have y equals negative 3. Factorize completely. 6x minus 18. The common factor is 6. When we factor that out, we are left with x minus 3. Factorize 25x squared plus 10x. The common factor is 5x. When we factor that out, we are left with 5x plus 2. T equals 8d minus 3. Make d the subject of this formula. When we add 3 to both sides of the equation, this is what we have. And when we divide both sides by 8, we have d equals t plus 3 over 8. Solve these equations. X over 6 equals 12. When we multiply both sides by 6, we have x equals 12 times 6. 12 times 6 is 72. Solve 7x minus 4 equals 3x plus 2. When we group like terms, we have 4x equals 6. And when we divide both sides by 4, we have x equals 1.5. Find square root of 320.41. When we type this into the calculator, we get 17.9. Find 6.4 squared plus 1.2 cubed. When we type this into the calculator, we get 42.688. Find the reciprocal of 2. To get the reciprocal of a fraction, we swap the numerator and denominator. 2 is the same as 2 over 1, and so the reciprocal of 2 over 1 is 1 over 2. Find 9 raised to the power 0. Any number raised to the power 0 is 1, so 9 raised to the power 0 is 1. Find 3 over 7 of $42. Off is times, so 3 over 7 times $42 is $18. Find 12% of $62. In this case, we have 12% times $62, which is equal to $7.44. Insert one pair of brackets in each statement to make it correct. To make this statement correct, we put a pair of brackets around 20 minus 5. 20 minus 5 is 15, so 15 divided by 5 minus 3 is 0. To make this statement correct, we put a pair of brackets around 5 minus 3. 5 minus 3 is 2. So 20 minus 5 divided by 2 is 17.5. Write one of the symbols less than, greater than, or equal to in each statement to make it correct. To help make the comparisons easier, we can convert the numbers to percentages by multiplying each number by 100%. So for this, we see that 70% is greater than 7%. Then for this, we see that 20% is equal to 20%. Then finally, we see that 37.5% is less than 38%. Write 90 as the product of its prime factors. 90 can be rewritten as 10 times 9. 10 can be rewritten as 2 times 5. 2 and 5 are prime numbers, so we circle them. 9 can be rewritten as 3 times 3. 3 is a prime number, so we circle both. So now we have 90 equals 2 times 3 times 3 times 5. We can leave our final answer like this, or because 3 appears twice, we can rewrite it as 2 times 3 squared times 5. Find the lowest common multiple of 35 and 90. First, we list the prime factors of 35 and 90. Now, we can map the prime factors on a Venn diagram. So now, the LCM will be a product of all the elements in the Venn diagram, which is equal to 630. Find the highest common factor of 35 and 90. We can find the highest common factor by looking at the intersection point between the prime factors of the two numbers, and this number is 5. AB is the diameter of a circle center O. C is a point on the circle and angle BAC is 52 degrees. Find angle ABC. An angle formed in a semicircle is 90 degrees. The sum of the angles in triangle ABC should add up to 180 degrees. So we have angle ABC plus 52 degrees plus 90 degrees equals 180 degrees. When we make angle ABC the subject, we get 38 degrees. The diagram shows the positions of town A, town B, and town C. The bearing of town B from town A is 42 degrees. The bearing of town C from town A is 146 degrees. Find angle BAC. On the diagram, we've marked the bearing of town B from town A, which is 42 degrees. And we've also marked the bearing of town C from town A, which is 146 degrees. And so angle BAC would be 146 degrees minus 42 degrees, which is equal to 104 degrees. Find the bearing of town A from town B. On the diagram, we've marked the bearing of town A from town B. To get this bearing, we first need to find this angle. These two are interior angles, which means they add up to 180 degrees. And so when we subtract 42 degrees from 180 degrees, we get this angle to be 138 degrees. And so the bearing would be 360 degrees minus 138 degrees, which is equal to 222 degrees. Triangle ABC is isosceles with AB equals AC. BCD is a straight line and angle ACD is 117 degrees. Find the value of x. Angles on a straight line add up to 180 degrees. So when we subtract 117 degrees from 180 degrees, we get this angle to be 63 degrees. Base angles in an isosceles triangle are equal. The sum of the angles in triangle ABC should add up to 180 degrees. So we have x plus 63 degrees plus 63 degrees equals 180 degrees. 63 degrees plus 63 degrees is 126 degrees. When we subtract 126 from both sides, we get x equals 54 degrees. Rita and Henry own an investment business. They share the profit in the ratio Rita is to Henry equals 3:5. In 1 year, they make a profit of $2,400,000. Calculate Rita's share of the profit. Rita's profit is equal to the ratio share for Rita, which is 3, divided by the total ratio of 3 plus 5, which is 8, times $2,400,000. This is equal to $900,000. Henry invests $160,000 at a rate of 2.5% per year compound interest. Calculate the value of this investment at the end of 3 years. Here is the formula for compound interest. Big A represents the final value of his investment, which is what we are finding. Small a represents the initial amount he invested, which is $160,000. R is the annual rate, which is 2.5%, and T is the time duration in years for the investment, which is 3. When we type this into the calculator, we get $172,302.50. Rita invests $12,000 at a rate of R% per year. The value of her investment at the end of 1 year is $12,408. Work out the value of R. In this case, we can apply the compound interest formula. Since we want to find R, we make R the subject, and this is what we have. Big A represents the final value of her investment, which is $12,408. Small a represents the initial amount she invested, which is $12,000. T is the time duration for the investment, which is 1. When we type this into the calculator, we get R equals 3.4. Rita and Henry decorate their office. The cost $C is $10,800, correct to the nearest $100. Complete this statement about the value of C. When we correct the cost to the nearest $100, we have C equals $10,800 plus and minus $100 divided by 2. So now the lower bound of C is $10,800 minus $100 divided by 2, which is equal to $10,750. And the upper bound of C is $10,800 plus $100 divided by 2, which is $10,850. So now we have C is greater than and equal to 10,750 and less than 10,850. 15 people take a test. These are the test scores. Complete the frequency table. You may use the tally column to help you. From the list, the scores that are anywhere from 0 to 10 are 3 in total. The scores from 11 to 20 are 2 in total. The scores from 21 to 30 are 5 in total. The scores from 31 to 40 are 4 in total. Then finally, the scores from 41 to 50 is just 1. Use your table to complete the bar chart. So on the grid, we draw a bar chart for the intervals with their corresponding frequencies as the height of the bars. On Monday and Tuesday, the probability that a train is late is 0.2. Complete the tree diagram. On each branch, the sum of the probabilities that the train is late and the train is not late must add up to 1. So to get the probability that the train is not late, we subtract 0.2 from 1, which gives us 0.8. Use the tree diagram to find the probability that a train is late on both days. This probability is equal to the probability that the train is late on Monday and the probability that the train is late on Tuesday. The probability that the train is late on Monday is 0.2. The probability that the train is late on Tuesday is 0.2. The end becomes times. 0.2 times 0.2 is 0.04. Use the tree diagram to find the probability that a train is not late on Monday and late on Tuesday. This probability is equal to the probability that the train is not late on Monday and the probability that the train is late on Tuesday. The probability that the train is not late on Monday is 0.8. The probability that the train is late on Tuesday is 0.2. The end becomes times. 0.8 times 0.2 is 0.16. The table shows some values for y equals x squared plus x minus 5. Complete the table. When we plug in x equals -3 into the equation, we get y equals 1. For x equals 1, we get y equals -3. Then for x equals 2, we get y equals 1. Draw the graph of y equals x squared plus x minus 5 for x is greater than and equal to -4 and less than and equal to 3. So on the grid, we plot all the points in the table and we draw a smooth line through the points. Write down the equation of the line of symmetry of this graph. The line of symmetry of the graph is this line, which is x equals -0.5. Use the graph to solve the equation x squared plus x minus 5 equals 0. To solve this equation using the graph, we need to find the x-coordinate of the intersection point between the graph and the line y equals 0, which is the x-axis. So on the grid, these points are x equals -2.8 and x equals 1.8. The diagram shows 4 triangles on a grid. On the grid, translate triangle T by the vector 2, -5. For this translation, the translation vector dictates that we move each of the vertices of triangle T 2 units to the right and 5 units downwards. On the diagram, the movement for point T has been shown. After repeating the same process for all the other points as well, we are able to map out the translated image of triangle T. Describe fully the single transformation that maps triangle T onto triangle A. When we look at triangle T and triangle A, they have the same lengths, but their orientation is different, which means the transformation is either a reflection or a rotation. In this case, we see that triangle A is a mirror image of triangle T in the line x equals 0 or the y-axis. And so the full description for this transformation will be reflection in the line x equals 0. Describe fully the single transformation that maps triangle T onto triangle B. When we look at triangle T and triangle B, they have the same length, but their orientation is different, which means the transformation is either a reflection or a rotation. When we rotate triangle T 180 degrees, we get triangle B. For a 180-degree rotation, we don't need to specify if it's a clockwise or anti-clockwise rotation because either way it's still the same. Now we need to find the center of rotation. For a 180-degree rotation, the way to get the center of rotation is this. We connect at least two corresponding points on both triangles and find their intersection points. When we do this, we get the center of rotation to be the origin. And so the full description for the transformation would be rotation 180 degrees about the origin. Describe fully the single transformation that maps triangle T onto triangle C. When we look at triangle T and triangle C, they do not have the same lengths. Each of the side lengths in triangle C is half the corresponding side length in triangle T. This means the transformation is an enlargement by a scale factor of half. We have a positive scale factor for this enlargement because the two triangles have the same orientation. Now, we need to find the center of enlargement. To get the center of enlargement, we connect at least two corresponding points on both triangles and find their intersection points. When we do this, we get the center of enlargement to be the origin. And so the full description for this transformation would be enlargement by a scale factor of half about the origin. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.